So, what are the clean code practices for classes? The higher level of code organization. To explore that, let's talk about the clean classes. So, we know that if we follow the Java convention, a class should begin with a list of variables, public static constant, if any, should come first, then private static variables followed by private instance variable. And there's seldom a good reason to have a public variable. Public function should follow the list of variables, and generally, we like to put the private utilities called by a public function right after the public function itself. And as per Robert Martin, the structure of your code, the piece of code, the program that you have written should follow the step down rule so that anyone can read your code like a newspaper article. Whenever we talk about the classes, the first thing that comes to our mind is encapsulation. And in terms of encapsulation, we generally like to keep our variables and utility function private. But at the same time, we are not that much obsessive about make marking everything as a private. Sometimes we make our variable or our utility functions protected or package scope too, so that they can be accessed by the test. So, a good rule is while deciding the encapsulation, look at the test. If the test is in the same package, needs to call a function or access a variable, we would prefer to make it protected or package scope. And in any case, we must try to maintain the privacy and to follow the open closed principle. That says that our entities should be open for extension but closed for modification. The next thing that we need to keep in mind for designing the clean classes is that our classes should be small. This is the first rule that we need to keep in mind. And as Robert Martin says, that the first rule of the classes is that they should be small, and the second rule of classes is that they should be smaller than that. And as with the functions, small is the primary rule when it comes to designing classes. But again, the question comes how is small? With functions, we measure the size by counting the physical lines, and with classes, we use a different method. We count the responsibilities. Remember the single responsibility principle. So, the name of a class should describe what responsibilities it fulfills. And as Robert Martin says, that in fact, naming is probably the first way of helping determine the class size. If you cannot provide a concise name for a class, then it's likely too large. The more ambiguous the class name is, the more likely it has too many responsibilities. And to test that, we can try a method. We can try writing a brief description of the class, say in about 25 words, without using the words like if, and, or but. And when we do that, when we put some effort to identify responsibilities in a class, it often helps us to recognize and create better abstractions in the code. So, SRP, Single Responsibility Principle, again given by Robert Martin, is one of the most important concepts in object oriented design. And it is also the most simpler one to follow. But ironically, it is also the abused principle, one of the most abused principle of design as well. So why does that happen all the time? Why do we violate this principle all the time? On that, Robert Martin perfectly mentioned that getting software to work and making software clean are two very different activities. Most of us have limited room in our heads, so we focus on getting our code to work more than organization and cleanliness. So, maintaining a separation of concerns is just as important in our programming activities as it is in our programs. But the problem is that we have this mindset that once the work is done, the program is working, it's all done. We do not recognize the other concerns of organization and cleanliness. And at the same time, some developers fear that a large number of small, single purpose classes makes it more difficult to understand the bigger picture. On the contrary, we must always remember that we want our systems to be composed of many small classes, not a few large ones. Each small class encapsulates a single responsibility, has a single reason to change, and collaborates with a few others to achieve the desired system behaviors. That should be our goal. Another important thing related to clean classes is cohesion. We know that classes should have a small number of instance variables. Each of the method of a class should manipulate one or more of those variables. In general, the more variables a method manipulates, the more cohesive that method is to its class. A class in which each variable is used by each method is maximally cohesive. But in general, it is neither advisable nor possible to create such maximally cohesive classes. On the other hand, we also want the cohesion to be high because when cohesion is high, it means that the methods and variables of the class are codependent and they hang together as a logical whole. But sometimes maintaining cohesion results in many small classes, so there is a contradiction. For example, if you have a large function with many variables declared within it, and you want to extract one small part of that function into a separate function, but the code that you want to extract uses four variables declared in the function. So, what would you do in this case? Will you pass all four of those variables into the new function as arguments? Not at all. Breaking a large function into many smaller functions often gives us the opportunity to split several smaller classes out as well. This gives our program a much better organization and a more transparent structure. Next thing that we need to keep in mind for designing the clean classes is that we are organizing our classes for change. In a clean system, we organize our classes so as to reduce the risk of change. We want to structure our system so that we don't mess too much when we need to update or when we need to add new changes. In an idle system, we incorporate new features by extending the system, not by making modifications to existing code. And we cannot avoid changes. What we can do is that we can isolate from change. To do that, we can introduce interfaces and abstract classes. They will help us to isolate the impact of those details. Why? Because dependencies upon concrete details create challenges for testing our system. Remember the dependency inversion principle, DIP. So what does DIP says in essence? It says that our classes should depend upon abstractions, not on concrete details. So these are some of the clean code practices that we need to keep in mind for designing the clean classes. And we can write clean classes and well organized system by keeping these things in mind. By the way, there are certain clean code practices for the system as well, and that we will discuss in the next part.